Sure.
Great, thanks, Haley. Welcome, everyone. So we're going to be talking about the 5G market today. Specifically, we're talking about CSP spend on 5G, and we're going to be sharing key findings from our recently published market forecast report. So let's get started. This is me. I'm Chris Antlitz, Principal Analyst, Telecom Practice at TBR. My email's there. Feel free to reach out if you feel so inclined. If you want to obtain a copy of the slides, please email webinars@tbri.com. We are not automatically sending the slides out. If you want them, you have to email us to get them. For this report, what I'm showing on this slide is the telecom research coverage. So this is the reports that the Telecom Practice TBR writes. The part in blue highlighting there is the report we're going to be presenting from today. But I just wanted to show this slide to show everybody the breadth of how we're covering the telecom ecosystem. It's a global coverage across some of the most important aspects of the market, including but not limited to 5G, private cellular networks, edge computing, and we also cover the hyperscalers in depth. For those of you on this call that are subscribers to TBR, highly recommend to check out these reports if your company has the access to them. So before we jump into the material, we need to go through taxonomy and make sure we're all on the same page with what's in the numbers, what's not in the numbers, and how we characterize 5G. So there's two main ways the telecom industry characterizes 5G. It's either an evolution of the access layer or a more broad definition, an evolution of the entire network. For the access layer evolution, it is the new radio interface and new mobile core that are significantly more powerful than LTE. And then the other way is end-to-end network evolution, which is a fundamentally new network architecture that is cloud-centric, software-mediated, programmable, intelligent, automated, and provides near real-time connectivity. For the purposes of this report and the data we're going to be sharing today, we are showing the access layer evolution side of 5G. So we're specifically sizing the radio and core opportunity that vendors sell into telco accounts. So I want to go a little deeper on that. And one second, Haley, are we recording? Because my platform is saying that we haven't started live yet.
Yes, it's live webcast in progress.
Okay, it might be an issue on my side, so I'll keep going.
Yep, if you, the slide progression might not be moving on yours, so I can deal with that on my end if you'd like.
Okay, I'm on slide 5.
Perfect.
Was it already on slide 5?
We were on slide 4.
Okay. I have quite a bit of animation, so I'll try and click through and just make sure that's working. So on the public 5G side, in the green box there on the slide, we are sizing the spend by CSPs on 5G infrastructure. And the telco, cableco, or hyperscaler must own that infrastructure to be included in the market size. We're also including network slicing, where a CSP is using its resources, partitioning those resources for use for like B2B use cases and things of that nature. So, Haley, did my animation go through there? And the first bullet on the right side?
It didn't go through, but I can control that for you.
Okay. So 5G telecom CapEx spend includes how much CSPs are spending on the 5G infrastructure, we include telco, cableco, and hyperscaler in our definition of CSP. Next bullet. I don't see it.
It's showing up on my end. Folks who are viewing live, are you able to see the animations come through?
Yeah, if you guys can just type on the Q&A if the animation's coming through, that would be good. We're on the first bullet point on the right-hand side of the slide. We're having some technical difficulties, so just trying to coordinate that. Okay. Okay, it says yes.
Perfect. Awesome.
So,
I'll just control on my end, Chris.
Okay, so I'm on the second bullet on the right. Hyperscalers, we consider CSPs because they're operating cloud infrastructure at scale and moving into the network operations domain. Third bullet, CSPs have to procure the infrastructure to be included in the market size. The fourth bullet is infrastructure that's resold by a telco to a non-CSP entity to build a private network is not included in the market size. So I want to be very clear about the distinction here. If there's infrastructure being resold for a private network, that is not included in the numbers we're going to be sharing. That's in a separate market size in TBR reports. On the fifth bullet, we're including 5G RAN and 5G core hardware and software, plus capitalized product attached and product near services associated with those products, such as deployment, maintenance, and professional services. So think about things like install, customer support, repair and exchange, design, plan, integration type services. We're including spend on that in the market sizing we're going to be sharing. The next bullet, on the radio side, we're including all hardware and software permutations, which includes the architectures as well as the spectrum band and form factors of NR. So DRAN, CRAN, ORAN, VRAN, we're including all of that. We're including all types of spectrum, and we're including all form factors of radios. So the data we're going to be showing is all in. The next bullet on the hardware side, we're including the RRUs, the BBUs, the front haul, and the integrated access backhaul if it's being used for VRAN environments. We're also including some site equipment like antennas. On the data center equipment side, which is required for VRAN because you're running the radio functions in a virtualized instance inside of mini data centers at the far edge of the network. So we are including the data center equipment that's associated with that. And then on the 5G RAN software side, we're including all software directly pertaining to the RAN, such as carrier AG, DSS, remote BBU upgrades from LTE to 5G. We're also including the virtual BBU in the market sizing. And then the last bullet on the slide, we're also including the 5G core, which includes the user plane functions, the control plane functions, the policy, and the subscriber data management. So I needed to put this slide in so that everybody's on the same page, what is included in the numbers we're going to be sharing. All right, so next slide. Unprecedented move by CSPs in China and the States is pulling forward the peak time frame for the 5G market. So in the center of this slide, you'll see a graph, and that graph has a blue line going across it. That blue line represents the global historical annual average CapEx spend by CSPs on RAN and core hardware, software, and related services. And basically, it's a $50 billion per year market, and the 5G spend cycle has been pulled forward. And typically, in prior radio generations, it took about 10 years for the globe to be fully blanketed in that cellular generation. The 5G is going to be deployed globally. It's looking like about 7 years. So that's about 3 years sooner than how the prior radio generations played out. And that spend is being pulled forward into the earliest part of the curve by what's going on in China and the US. So when we say 5G is peaking in 2022, that is directly correlated with the spend cycle in China and in the US market. And we're going to show more detailed breakouts of when the timing is in China and the States, base station counts, et cetera, that are showing us that that is in fact going to be the peak year. Now, after this year, it's going to be a drift lower as China and the States go post-peak spend, and then other markets in the world are going to play catch-up. So if we do the next piece of animation, we have key growth drivers. A variety of things are pushing this market to develop in this manner. One is we have broad 5G smartphone options already available. iPhone and Android options, all different form factors of devices, and they're available across many countries of the world already. So that's helping adoption. The second thing is competitive pressure among CSPs. CSPs are trying to one-up each other on how they're deploying 5G, and there's the marketing component. So if the competitor has it and the other telco doesn't have it, that puts them at a churn risk and maybe a pricing risk. They need to stay competitive there. We have DSS, which enable telcos to pull forward investment by upgrading existing LTE base stations to 5G. Our estimates suggest there were over 10 million LTE base stations globally that were compatible with a 5G remote software upgrade. And what we've seen is that most of those base stations have been already upgraded to 5G. And they're using DSS to bridge that. So they're basically using an LTE and a 5G signal out of the same base station. Now, there have been some technical issues with DSS, many of which have been worked through, but that was an opportunity for telcos to leverage existing infrastructure at a more cost-effective manner to introduce 5G NSA into their networks. And it gave them a time-to-market advantage. We also have fresh spectrum, licensed and unlicensed. We recently had the auction in India, so we're going to see 5G networks in India start to ramp up next year. And we've had a variety of spectrum auctions in other countries of the world driving this market forward. C-band probably being the most well-known and helping the states to peak in this year. We have government support and stimulus, various programs, bridging the digital divide, national security programs that are available that telcos can tap into for infrastructure development. There's also fixed wireless access and capitalizing on the work from home opportunities to provide broadband connections to remote workers is driving 5G. You can get a 5G high-speed internet connection out much faster than if you're deploying a fiber-based connection. It's significantly faster, and we're seeing telcos exploiting that opportunity. And then last but not least, of the drivers we have listed here, by no means is this all of them. There were use cases that were deployed during the pandemic, many of which remain in force today, that are using 5G technology, and those were a key driver of investment in 5G. On the detractor side, the next piece of animation on this slide, there's a variety of headwinds that are facing the 5G market. One is the complexity of the technology And we're going to get into this on the open virtual RAN side of the equation. Tremendous complexity, and it is slowing things down. It is slowing down adoption. It's slowing down the ability for those technologies to scale. COVID-19 has an impact. It still is having an impact in China in the supply chain. It's having a broader impact on the global supply chain. We still don't have headcounts where they were. People coming back to work is still a chronic issue. These are all things that are factored in. It has slowed down the standards creation. That is still an issue, though things are getting better. There's policy roadblocks in places like Europe where there's privacy considerations. There are societal considerations for 5G that are putting up roadblocks. We also have network sharing, spectrum availability in certain countries. There's been delays. That is pushing out timelines for deployment in certain countries. And then we have LTE being good enough for mobile broadband. So the reality is that many consumers are sticking with LTE because they're trying to keep their devices longer, and they're not obsolete yet, the devices, so they can still get some play out of them. And they're maybe waiting for a device that is justify them to upgrade. We'll see what happens with the iPhone 14. There's a lot of hope that that device set will drive 5G adoption. But there's going to have to be key features in those devices that push people to upgrade from their LTE devices into 5G. So kind of dynamics of the 5G market. When we net out all of the drivers and headwinds, we get a market development that looks something like this. And of course, factoring in the economic backdrop. With 5G though, as we're going to get into, one of the key justifications for telcos to invest in 5G is the cost efficiency that they get from transmitting data. So what that means is 5G is up to 10 times more efficient on a cost per bit basis versus LTE, depending on how the network is architected and the spectrum bands being used, up to 10 times more efficient. If you're a telco that's facing the inexorable rise in data traffic, which all of them are, that is a key business case for wanting to deploy and ensure that 5G is broadly deployed across a network. And the revenue is taking a secondary consideration to the margin structure and the competitive dynamics for 5G. And the revenue still is not materializing in the way that the industry was originally anticipating, with the notable exception of fixed wireless access, which is driving new revenue for telcos. And we're going to get into that in upcoming slides. If anybody has questions, just add it to the Q&A box, and we'll go through them one by one at the end. We have sufficient time to get through everything. So on the next slide, I want to talk about OpenVRAN specifically. And if we go to the first piece of animation, how do we define Open Virtual RAN, and why is it so important? We view Open Virtual RAN as the end state of RAN architecture. This is where everybody ultimately wants to be. And there's reasons for that. There are key attributes in that architecture, benefits that could save telcos conceivably many billions of dollars in CapEx per annum on the radio side of the network. And there's also the benefits of flexibility, of introducing new services faster, of supporting network slicing at scale, of doing zero-touch automation of the network. Open Virtual RAN theoretically opens up a whole host of benefits to telcos. The problem is that it is incredibly complex technology to deploy at scale. The attributes the characterizations of OpenVRAN, it's fully virtualized, it's cloud native, it's microservices based, it's an open platform running on COTS hardware such as x86 or ARM servers, hardware agnostic, cloud agnostic, it's fully automated, and it's intelligent. This is not a full list of attributes, but when you think about Open Virtual RAN, I want everybody to think about it characterized as meeting this criteria. And the next animation, these attributes also apply to an end state 5G core. So I'm specifically talking about a 5G fully standalone core meets all of those attributes. The graph on the top left, the top right-hand side, the next piece of animation shows the traditional RAN versus the Open RAN and vRAN market size. So traditional RAN is going to be around for a very long time. OpenVRAN is not going to replace it anytime soon. However, if we go to the next piece of animation and we look at the mix, in 2026, we're estimating that 30% of the global RAN market is going to be Open RAN and or vRAN. So it's and or. So what we're seeing is there are many telcos out there that are running vRAN today, according to our definition, but the RAN is not open. It's a proprietary system. And that's fine. We're including that as next generation architecture en route to that end state where it's Open RAN and vRAN combined in the same architecture. So 30% in 2026. It's going to be a slow going, but once some of these technological hurdles get worked through, we're going to see that market start to scale more and more, especially in new spectrum bands and in markets where there is strong demand for 5G. We're going to see vRAN be deployed much faster than in other markets on a relative basis. Okay, if we move to the next slide, what we did is we took the 5G infrastructure spend by CSPs and we parsed it by, okay, what % of that infrastructure is going into each main use case? And we've got mobile broadband, so eMBB, fixed wireless access, and then other use cases. It's a catch-all bucket. That's everything that's net new. So think about IoT, B2B type use cases for the network. Think about things like drone delivery. But things in that nature. Connected car would be included in other use cases. Despite what the hype is for 5G, the reality is that thus far, and for the next few years, the vast majority of 5G infrastructure is going into traditional use cases of the network. Traditional being enhanced mobile broadband, so smartphone subscription, how do I give a better QoS over that? How do I do that more efficiently, right? We talked about why 5G is much more efficient than LTE. And then on the fixed wireless access side, it's about how do I provide high-speed internet service in a more effective way, maybe a more cost-effective way, and how do I get it into the field much faster? So a time-to-market advantage. We see T-Mobile and Verizon doing this in the States at scale. And there's well over 150 telcos in the world that are also deploying fixed wireless access. This is a significant use case that telcos globally are looking at. And that is driving new revenue. Fixed wireless access is a net new revenue driver for telco. What we're seeing is that those new subs are coming from people that were previously unconnected, or they were people that were an existing connection of another ISP, like a cable company, that was either dissatisfied with their service or just wanted a lower price point, and they churned out to a telco. We're seeing a lot of that in the States. to the tune of hundreds of thousands of subs so far this year have made that move just for that reason. So then we have other use cases which will develop over time. We're still waiting for standards like URLLC and some other key standards for connected car and machine communication, where it's going to open the door for commercialized, scalable solutions for leveraging public 5G networks. The other thing that's delayed is network slicing. The reality is that network slicing today is nowhere near what the theoretical outcome of network slicing is going to be. Today, network slicing is possible, but what I've seen is it's manually intensive. It is not automated, and it's not real time. It needs to become more automated and scalable, and it needs to be able to be more flexible to autonomously configure network resources to the specific needs of use cases. The industry is still working on this to automate these things and to make it work with much less manual intervention. So we're going to get there, but there is a time to market delay for true network slicing using a 5G fully cloud native standalone core. Okay, next slide. So now what we've done is parse the market by tier of telco, by tier of CSP, because remember this includes hyperscale and cable as well. So tier 1 is 50 million or more mobile connections. Tier 2, so a mobile connection can be a smartphone, FWA, IoT connection. All of those would be a count of one connection. And then we look at, okay, we stratify the telcos and say, okay, well, relative size of telco based on what kind of connection counts they have. So we also are including hyperscale in tier 1. So Rakuten is in tier 1. As we know, Rakuten is building that mobile network in Japan. We consider that a tier 1 CSP in how we delineated the data set. What we see here is that the vast majority of 5G spend is and will remain by tier 1 telco globally. So think about the top 50 CSPs plus the hyperscalers. Those are the ones that are really driving 5G, and they will be for the foreseeable future. Tier 2 is going to grow over time. There's a lot of smaller telcos that are, for whatever reason, a little bit slower to do nationwide 5G network deployments. I'm thinking about Europe. I'm thinking about areas of emerging markets where it's been a little bit slower deploying 5G, especially outside of urban centers. It's going to take a little bit more time for that to play out. And then tier 3 is going to lag. What we're seeing in many cases, tier 3 operators are sticking with LTE. It's getting harder for them to justify the investment in 5G until a very clear business case materializes. They also have more resource constraints than the larger telcos have. So there's some considerations for subscale telco, why they would be delayed in when they actually deploy 5G networks to cover their footprints. On the next slide, on the first animation, we broke down the 5G market by region. So we have North America, CALA, EMEA, and APAC. What we see from this analysis is that, as we said before, China and the US are driving. Essentially, they're driving well over half of global spend on 5G infrastructure. Just those two countries are spending well over half of the global spend on 5G infrastructure. So it's unprecedented, the amount, and that is the key reason why the market is going to peak in 2022, because they move the needle so much in infrastructure spend. That's why that peak of the curve timing is at that time frame. Just to give you some data points, as of the first half of this year, China has deployed over 1.7 million 5G base stations. That is a massive number of base stations on a country basis. Even in relative to their population, that's a massive number. Per site, it's very, very high. China is expecting, they are planning to deploy another 1.3 million base stations for a total of 3 million base stations by the end of 2025. That is a much higher figure than the numbers in the States. Just to give you a context of sheer magnitude of infrastructure investment. China spend peaks this year, and then it's going to start to drop. From what we've seen, the peak intensity of unit counts in China is going to be this year, and then it's going to start to trail off next year. Same thing in the States as C-band deployments shift to the next phase from covering the majority of the population to covering the last portion of the population. Think about filling in the gaps of the map, that stage of the deployment. There's usually a longer tail to cover that at a lower spend. When we look outside of China and the States, CALA is going to be a slow mover. EMEA is proving to be a slow mover. In parts of Europe, there is strong investment in 5G. But if you look at EMEA as a whole, spend on 5G is slow. There is some pandemic funding available for bridging digital divide that some telcos are using in the UK and France especially. In Germany and in Spain, there's also some funding available. So there are some pockets of government money to help subsidize infrastructure development, and we are seeing some of that helping prime the pump to push forward infrastructure investment. If we do the animation and go to the next chart on the slide, this is another way to look at sheer magnitude. China is spending well over 40% of global 5G infrastructure this year. Just that one country is almost 44% of global spend on 5G infrastructure. And the timing of their peak coincides with global peak spend. Okay, so let's move to the next slide. We're going to move to key takeaways and then move to Q&A. So China and the States are really moving the needle for the global 5G infrastructure market. If we go to the first piece of animation, the first bullet point, the justification, the primary justification that we've seen for telco investment in 5G is for cost efficiency and competition parity. Revenue growth, it has become a secondary consideration for telco. They're basically building the infrastructure and hoping the revenue is going to show up. Now, for fixed wireless, there is an opportunity there. But beyond fixed wireless, the business case and the ROI becomes much more hazy and unclear. We're still waiting for use cases that are going to be a quote-unquote killer app for driving B2B new revenue for telco in the 5G domain. It has not materialized yet. Still waiting as an industry. The second bullet, FWA is scalable, it's revenue generating, and it has a positive ROI from the telcos we've analyzed. So a company like T-Mobile, for example, I would argue they're one of the best examples of a telco that is taking the FWA opportunity and running with it and fully maximizing the opportunity there. That is a significant multi-billion-dollar revenue top-line opportunity just for that one telco. We could see FWA generating just for T-Mobile several $1 billion in new top-line revenue over the next few years. It's very significant. And they can't really do that with LTE because they couldn't have done it with LTE because they didn't have the spectrum depth and the propagation characteristics and the characteristics of operating 5G in mid-band spectrum enables the company to scale and provide a good QoS that's competitive with cable offerings and other ISP offerings. So 5G really enables FWA to compete on par with traditional high-speed internet options. The next bullet point, it's going to take time for OpenVRAN to mature and go mainstream. We're seeing that. We're seeing those challenges. They will be worked through, but it's going to take time. We are seeing a lot of proprietary vRAN scaling, especially with Verizon. A lot of that C-band build is virtual RAN, and that's a key driver. AT&T is also doing a lot of vRAN, and there's other telcos around the world, mostly tier ones, that are starting their journey of deploying commercial OpenRAN and or vRAN infrastructure. Next bullet point, China is leading by a significant amount. That bears true through just the sheer amount of infrastructure, the amount of POPs per site that are being deployed. Those types of metrics would yield that conclusion that China is significantly ahead the rest of the world in 5G development. And then last but not least, Europe and emerging markets are lagging in 5G. And they're slowly catching up, but it's really going to be dependent how fast those countries ramp up investment. Government stimulus is certainly going to help. It is helping. But the regulatory environment, the business case for certain countries, those types of things need to get worked through before we're going to see much broader, like nationwide 5G networks be deployed at scale. All right, and with that, we can move to the next slide, and we can open it up for questions. So I'm going to go to the first question here. Again, if anybody wants to submit a question, just go to the Q&A box at the bottom of the platform. There's a button there, and you can type in your question. The question is upcoming 5G advanced spending factored in as well? Yes, it is. We did factor that in. And 5G advanced is still early days. So, but by the end of the forecast period, that definitely plays a role in market development. But coming back to the standards, the pandemic really slowed down the standards process. And I don't think it is talked about enough in the industry how important 3GPP is to driving the global 5G infrastructure ecosystem, not only on the infrastructure side, but also on the device side. During the pandemic, there was a lot of slowdowns in coordinating the talent resources to finalize standards. The whole process got gummed up, and they're still working through that. Even now that the pandemic is subsiding, they're still working through the delays there. And that is slowing down the pace with which enterprise, more of the B2B type use cases, those features are getting ratified. It's slowing down 5G advanced. It's delaying some of those things that are going to help the other use cases side of the equation to scale. But it'll come. It'll come. It's just going to take some more time. All right. The next question is, how does private 5G factor into these trends and enterprise customer adoption of 5G? So coming back to the taxonomy, what these numbers are showing is just public 5G spend. So this is for WAN networks deployed by telco, cableco, and hyperscale entities. When an enterprise is procuring a private 5G network that they own and control, those are key words, that spend is in a separate market size in terms of how TVR characterizes the market. So we have separate webinars on private networks and separate reports sizing that opportunity. If the telco is providing or reselling a private 5G infrastructure for a private 5G network that the enterprise owns and controls, that also is excluded from this market size. So I want to really demarcate a public network from a private network where the telco is maybe partly involved in some way, but the telco is not directly controlling and they are not owning and operating that infrastructure. There's a delineation there with some gray area, but that's how we delineate between a private network and more of a public traditional way of building a network. If that doesn't make sense, just send a follow-up question in the thread and I'll come back to that. I'm moving on to the next question. With FWA being the key driver, how do you see 5G slicing, and do you believe application slicing will be relevant to provide a differentiator on the security side? It will be a differentiator, but who is that differentiator going to help? So where we see this going ultimately is that the networks are going to resemble clouds. So we all see the trend of the network going into the cloud. But what the big change is going to be is network resources becoming configurable inside of cloud ecosystems. And what that means is cloud marketplaces and cloud platforms will offer configurable, scalable network resources anywhere in the world for networks to be constructed. That's going to be a game changer. So what that means is, let me give you an example of this. Let's say a telco wants to deploy OpenVRAN certified infrastructure at scale in their network. They might go to a cloud marketplace portal and pull down the partners, the software layer, and the security features that they want embedded into that solution, and then have an ecosystem of partners deploy that infrastructure on their behalf. Enterprises are going to do this as well. It's very similar to how cloud resources are configured today, except that that now is extending from the IT domain into the network domain. So when we think about the evolution of procurement models for network infrastructure, slicing will play a key role in that. And then the differentiators and the innovation on the application layer will be exposed through those platforms, ecosystems, and marketplaces. And yes, I'm implying that the hyperscalers are going to play a very important role in this, and I believe they will. They already do, depending on how that's viewed. That's really where you're going to see the innovation and the monetization opportunities open up on the on the application slicing side. That's my personal opinion, but that's where I think we're really going to see true B2B innovation in the 5G ecosystem. All right. If I'm not addressing the question, just add a follow-up to the Q&A. We can come back to it. Next question is, okay, so the follow-up to that prior question is enterprises bring your own device security independent of the VPN. I think that's more on the device side and more on the SD-WAN side. I think that there is going to be, ultimately network slicing is going to straddle that. It's going to have to, but I think it's too early days in the context of public 5G networks using network slicing to make a prediction on that. So I'm going to have to hold off on that one. All right, any other questions? Okay. So Haley, I'll hand it back over to you.
Thanks, Chris, and thanks, everybody. Please feel free to reach out to Chris if you have additional questions. If you have a few moments, it would be super appreciated if you could fill out the survey on your screen. A replay version of today's webcast will be available after the event and will be sent out to all of you via email. To view a list of our upcoming and past webinars, please visit tbri.com. And if you're interested, be sure to join us on Thursday, September 22nd for Inflation, Recession, and Uncertainty, 3 Key Drivers of Cloud Economics. Thank you all for joining and have a great rest of your day.